Hi again, class. Now what we're going to look at is graphing lines in slope-intercept form. We should have already figured out how to identify the slope and the y-intercept in a line that's already in slope-intercept form, and now we're actually going to use it to graph these equations. So the first thing I need to do is I need to make sure that my line here is in slope-intercept form. And we know slope-intercept form is all in the form of y equals mx plus b. Which obviously the two parts that we have talked about already in class is identifying what is the slope m, which we define as a change in y over our change in x, which is also a rise over our run. Now that's something we've been studying this past week or two, and something that has been reoccurring through all of the equations that we've studied thus far. The other thing that we need to figure out in our line in order to graph it is we need to find what our y-intercept is, which is our b. And we know that our y-intercept has a coordinate where the x value is always 0, and then there's some y value. And this specifically will be on the y-axis. That's something we studied with quick graphs, where, if you remember, we had our x-axis, our y-axis, then we found our y-intercept, our x-intercept, and we were able to graph a line from it. So we're going to be doing something similar, graphing these lines, but the only difference is now I just need one point, my y-intercept, and my slope, my change in y over change in x. So the first thing we have to do is identify what our slope is and what our y-intercept is. So based on my equation here, I first have to ask myself, is this line in slope-intercept form? So is it in y equals mx plus b? So when we look at that, we want to know if this is 1y, because that's how we would read it. It is a 1y. So let's take a look. If I were to write exactly or directly above my equation, is that line y equals negative 3x plus 2 in slope-intercept form? And because I have 1y, it's on its own side. It is in slope-intercept form, therefore I can identify right away my slope and my y-intercept. So I ask myself, what is in the place of m, my slope? Well, if I take a look at my equation right here, it's that negative 3, which therefore my slope is a negative 3, and we always write our slope as a fraction, negative 3 over 1. Because negative 3 divided by 1 obviously still gives us that negative 3. So I've taken care of my slope. The other thing I have to take care of now is my y-intercept. Well, what is in the place of my y-intercept? Well, that would be this positive 2 right here. So therefore, my y-intercept, I know the x value in the coordinate is going to be 0, and the y value is just that positive 2. I take that sign with it. And now, I have plenty of information in order to graph my line. So the first thing I have to do, obviously my axes here, they are not labeled. So first thing, I must label my axes, x horizontal axis, y is the vertical axis. And now I get to the actual graphing. Well, on this line, or excuse me, in this actual coordinate grid, we have only one coordinate that I can actually identify right now, and that is our y-intercept. So I can actually plot 0, 2. So I come into my y-axis, which is my horizontal, or excuse me, my vertical axis, and then I move up to 0, 2. 1, 2. That's the first point we have plotted. And now, from here, it's very simple. We are going to use our slope. And here's our slope right here. It's negative 3 over 1. And remember a little earlier, we talked about this as our change in y is over our change in x. And we want to be specific when we actually graph using the slope. Meaning, my change in y is represented by this negative 3. So when I say be specific, what we're talking about is, are you moving up or down? And specifically on the y-axis, that's the one that actually moves up or down. So if I take a look at that negative 3, I would move down 3. So I count down 1, 2, 3. And I hover there for a little bit, because if I just plotted this point right here, if I just plotted that and I try to graph it, I would just be regraphing my y-axis. And that's not the actual line that we want. So that is an incorrect mistake that we want to make sure we don't compute when we're actually figuring out what this line is. So again, I come in here, my change in y is negative 3, so I'll go down 3, 1, 2, 3. And now my over. Be specific with this over. You have to start thinking about this. If this is a negative 3 up here, this also down here has to be a positive 1. So therefore, if I'm running and my change in x right here is a positive 1, think about that as a number line. Would that be to the right or to the left? That would be obviously to the right. So again, just a I'm going to drop down 3 for my change in y, down 3, and then to the right 1. And now I go again from the same point. I use that same slope again, so I drop down 3, 1, 2, 3, because it's the negative 3, and then I move over to the right, be specific with which direction over, 1. Now, there's also one more thing I could do. If I wanted to go backwards, here's a little hint. Let's say I can't go down into the right any further, but I wanted to plot all the possible points on this actual coordinate grid. I could go back to my y-intercept, and instead of going negative 3 over positive 1, I could go in reverse and have a positive 3 over negative 1. And what would that mean? Well, that would mean my change in y would actually be up 3. So I count up 3 here. Then my change in x is negative 1, meaning left 1. 1, 2, 3. To the left 1 would be backwards. And if you look at it now, my guys always know we have to check our work. We read our graph from left to right, and let's see, our slope is negative. Are these points going down? Let's see from left to right. Are they going down? They are. So therefore, this slope actually makes sense with our graph. From there, it's nice and easy. Draw your line as closely as possible. Obviously, if you have a ruler, put it through there. I know, because you guys are going to look at this and say, well, it's not a straight line. You can draw that a little straighter. That's a little bit better. There you have it, graphing lines in slope-intercept form. So here we go, one more example, this time with a fractional slope. First of all, is my line in slope-intercept form, which we know slope-intercept form is y equals mx plus b. Well, do I have one y here? I do. Is it all by itself? It is. It's all on the left, and therefore I can identify my slope and y-intercept. My slope is 2/3, positive 2 over positive 3, and my y-intercept is that coordinate 0, negative 5. Now I have to label my axes, x and y, and now I'm going to go to that first coordinate, which was 0, negative 5. I go to my y-axis, 1, 2, 3, 4, 5. Down 5 because that's 0, negative 5. And now I use my slope. So from here, I'm going to use my slope, and I'm going to go up 2, because this is a positive 2, up 2, and then to the right 3. 1, 2, 3. Let's see if I can get one more point. I can go up 2 again, to the right 3. I get that in, and now I can draw my line. Arrows on the end because that line continues on forever. Now, just to make sure that my line is correct, my slope was positive here, so I can, as I move from left to right, the way we read our graph, is our slope going up? Let's see. As I move my pen from left to right, that line is going up, so at least our answer makes sense. So what you're going to do now, you're now going to get into the worksheet that was provided for you. You should have taken notes on all of this, so please use your notes. You may refer back to the video at any time to help you if you get a little stuck on any of those problems from today.